Today we are going to be learning how to solve quadratic equations in 4 different ways. Using the equation negative 2x squared minus x plus 6 equals 0. By the end of this presentation, you will be able to solve quadratic equations in 4 different ways. Before you even start solving a quadratic equation, first you need to find a discriminant. What's a discriminant? A discriminant is essentially a number that indicates the solutions of a quadratic equation. It does not give the actual solution, but it does hint at what the actual solution will be. The formula for finding the discriminant of a quadratic equation is b squared minus 4ac. In this situation, our a term will be negative 2, our b term will be negative 1, and our c term will be 6. If there is a positive value when you plug the numbers in for the solution, when you plug the numbers in for the variables, then you will have 2 x-intercepts. If it equals 0, then you will have 1 x-intercept. And if it equals a negative number, you will have no x-intercepts. The reason for this is when on a graph you are using the parabola. If it has a positive solution, that means that it will touch the x-axis in 2 places. 0, the vertex, is what's on the x-axis, and none, it does not cross the x-axis at all. You may be wondering where you get the formula for finding the discriminant from. You actually get it from the quadratic equation that you use to solve the equation for itself for its solution, which we will get back to later. But since you cannot find the square root of a negative number, as it is an imaginary number, that indicates the fact that you will get no solutions for an equation. The same applies for the other situations. Now, when finding the discriminant of the equation itself, for the equation that we have provided, negative 2x squared minus x plus 6, we will need to first substitute the variables in for the actual values, and then if we solve accordingly, we will find that we have a positive solution indicating that there are 2 x-intercepts for this equation. Now if you start actually solving the quadratic equation to find the solutions, first we'll start with graphing, and I drew a happy person because graphing is easy, or rather finding the solutions from a graph is easy. They're basically laid out for you. So I used Desmos to make a graph of my equation, which if you remember is 0 equals negative 2x squared minus x plus 6. One thing you'll find some important features about the graph you'll find at first is the y-intercept is 6. This is because the c term is 6, and as you may know, the c term is the y-intercept. Then you have the vertex. In this case, the vertex is a minimum point because the a term is negative. Now, then you'll find these solutions, which cross the x-axis. Negative 2 and 1.5 equal x. And that's it. To find the solutions of the graph, that's all there is because they were basically laid out for you. Back to the vertex. How do you find the vertex of the graph if you don't have the graph with you? Well, use this formula. V will stand for vertex. Negative v over 2a, which if you recall, looks quite similar to a part of the quadratic equation. But again, we'll get back to that later. Now, in this situation, if we plug in the variables, it will be so if you take this and you divide it by, you will find the x value. Now, you have to go back and solve to find the y value. Since this is the x value, you'll need to plug into the equation. And when you do so, you'll get 6.125, such as it is illustrated here. That's how you find the vertex. Now, the line of symmetry is essentially the x value of the vertex, but only on an equation on its own. So, it is just x equals negative 1/4 is the line of symmetry. The line of symmetry is the line that passes through the vertex that shows the mirroring on each side of the quadratic equation. The next way you can solve quadratic equations is by factoring. When you factor, you use the cube like this and you insert the terms corresponding to the variables I have placed. The b term goes in the square in the middle, the c term goes in the square in this area, and the a term goes in the square in this area. Essentially what you want to do is to make it work similar to a multiplication box, in which the top terms and the side terms get multiplied to get terms corresponding to the boxes they are lined up with. The middle box is where the terms added on these two boxes, they add to the middle term. Now if we use the factoring box with our own, you'll see that first, before you factor anything, you'll take out what is a prime number in any of the boxes so you can find the factors. In this case, it would be -2 and x. You could have also put -x and 2, but it would have been harder to factor out later. So, it is easy to do that. Now, we need to think of terms that will add to -x or -1 that multiply to 6. However, when it also is multiplied by -2 or x according to these boxes. Unfortunately, there are no variables that add up to -1 that will multiply to 6 when also provided with these factors. This is because the factors of 6 are 2 and 3, and 6 and 1. When you pair it up with these, it will come up with the result -12 and 1, which when added equal 11, or vice versa, which does not work either. 2 and 3 would work if we did not have a coefficient of 2. So, it is impossible to factor this. That does not mean there are no solutions to this equation. This simply means that that one or more of the solutions is a fraction or a mixed number. Another strategy we can use to find the solutions of a quadratic equation is called completing the square. Essentially what this means is that you are taking the equation and divvying it up into geometric shapes, in which case it's called completing the square, so you will find the solutions and values in order to find the square of the equation. This will make more sense when you actually start solving it. First, we write out the equation. -2x squared minus x plus 6 equals 0. First, we have to divide the coefficient to make it so that x is equal to 1, or 1 of the x squareds only, actually, in which case it will be impossible to use this strategy if you have a coefficient more than 1 on the a term. When we do this, we get x squared plus 1/2 x minus 6 equals 0. Next, we move the c term to the other side of the equation. This is because this is not already factorable, or a square. So we need to make this side a square. How do we do that? Well, we have to find the c term for this side now. In order to find the c term, we take half of b and square it. In this case, half of b is 1/4, and when you square that, you get 0.0625. Now, in order to make my job easier, I will convert the rest of these numbers into fractions. Now that we have our additional value, first, after this, we need to add, whatever we do to one side of the equation, we need to do the other side of the equation, in which case we need to add 0.0625 to this side as well, resulting in 6.0625 on one side of the equation. Now we factor this equation. Simply, since this is a square, you will end up with x plus 1/4 squared, which is equal to the solution we got previously. Now, here's when completing the square comes into play. Since this is a square already, we take the square root of both sides. Since this is already squared, we simply just copy down the original expression without the exponent. And now, the square root of this side can either be positive or negative 1.75. Now, to solve this rest of the equation, we simply divide it into two separate ones. One in which we subtract 0.25 from 1.75, and one in which we subtract it from negative 1.75. When you do this, you will get x equals 1.5, or rather, and x equals negative 2, which are the solutions to this equation. So, completing the square is essentially many steps, but first you make a square root out of one side. First, you make a perfect square out of one side of the equation. Divide both sides to find the numbers and the solution to the equation. The final way to solve a quadratic equation that we will be discussing today is using the actual quadratic formula, which is a formula designed specially to find the solutions for a quadratic equation. Now, it is in the form x equals negative b plus or minus the value of the square root of b squared minus 4ac all over 2a. As you have seen, we've had examples of this with parts of this equation taken for other parts. And now you finally get to see the entire equation. Now, we simply have to plug in values for this. When we do so, we plug in our b term, and our b term. We plug in our a term and our c term. When you multiply it all out, we'll receive positive 1 plus or minus the value of value 1 plus 48 all over negative 4. Next, we will add what is in the square root, which equals 49. Now, first we can consider this in two different ways. We can consider it as positive or negative in 49, or the square root of 49 rather, which is 7. Now we can do negative 7 minus 1, negative 7 plus 1, or we could do 1 plus 7. both of these will be over 4. When you do one of them, minus 7, you will receive negative 6 over 4. Negative 4. Negative 6 over 4, which is negative 6 over negative 4, which is 1.5. Now when you solve accordingly for this, you will receive negative 2. These are the solutions we have found throughout the other strategies, and although the quadratic formula is a slightly more tedious way to solve the equation, it does get the job done. Usually you use this as a last resort. If the equation is not factorable, if you do not have access to a graph, and if completing the square is not easy, especially if the coefficient is more than 1 and will result in complicated fractions to use, the quadratic formula is usually the route you want to go. That wraps up our lessons for today. Thanks for watching.